Okay, YouTube, in this video we're going to be working on is kind of identifying and sketching angles that are listed in a radian measurement. And so this is something new for a lot of people, and we're going to kind of build off of some pretty basic facts, starting with what you see over here on the left, which let's go ahead and start with this. We say that one revolution around a circle, or at least one full revolution in terms of rotation here, is 360 degrees, but is also 2 pi radians here. And so using that, what we could kind of look at is here, well, what if we had a 3/4 revolution? That'd be 3/4 of 2 pi, and that would be 3 pi halves. And we just get that by taking, 2 pi times 3/4, which we would get, I suppose, 6 pi fourths. But it's the same thing as 3 pi halves. But you can see that 3 pi halves radian rotation here would be 3/4 of a rotation. A half of a revolution, well, that'd be half of 2 pi, which is just pi. So we'd say pi is a 180-degree angle, or a straight angle here. And then half of that would just be half of this pi, which is pi halves, or 1/4 of 2 pi. Remembering that 1/4 of 2 pi would be the same thing as multiplying straight chords here, 2 pi fourths, which is a pi halves. And so what you're seeing here, these four basic angles, what I want to kind of indicate is that these are all kind of increments of 90 degrees on each one here, 90, 180, 270, and 360 in terms of degrees. But in terms of angles, these are really increments of pi halves. And so what you're seeing here is if we were to take, say, really the xy coordinate plane and do this rotation right here, this would be a half of a pi rotation, because a pi rotation would be all the way over at 180. But that's 2 pi halves rotation. This is 3 pi halves rotation. If we were to go another pi halves rotation, then all the way around would be a 4 pi halves. But you can start to see how managing rotations around this really is just kind of accumulating a certain number of, I guess, sized increments of rotation. So in this case, we have a number of pi halves, 1, 2, 3, or 4. We could keep going, but we're just navigating by pi halves increments. And so what's going to be very, very helpful, as a matter of fact, when you start to navigate in radian measurement, is to start to get an overall picture of the type of angles that you're going to see. And so where I'm going to direct everybody is basically starting down at these two empty diagrams that you see here. And so easy ways to kind of navigate in terms of radian measurement, or at least with common angles, are to split this circular region up into either 8 pieces or 12 total pieces here. And the reason why is because we're going to look at angles that, let's go ahead and label some that we know. We know that this is 0 or 2 pi here. And we know that 180 degrees is the same thing as pi radians, and that this is pi halves. Okay. What we're going to see here is this. By splitting this all up into 8 equal sized pieces, that'd be 1/8 of the total 2 pi. That's the same thing as 2 pi eighths. Or in other words, what we're seeing here is that we are going around by pi fourths increments. So what we're seeing here is this. If this is pi, you'll notice that this top upper half has been split up into 4 different equal sized pieces. Each one is a fourth of pi. And so what we're going to say is that this is pi fourths. We're going to say that this up here is really 2 pi fourths, which is the same thing as 1 pi half when we reduce it. This is 3 pi fourths right here, where we've got 3 of these pi fourths, or 3 of these 45-degree rotations. And then this here would be 4 of these pi fourths, or in other words, a full pi, 4 pi fourths. So going around, we say 5 pi fourths would get us to here. This one here, of course, would be 6 of these 45-degree angles, or we also refer to this one as 3 pi halves. And this down here would be 7 pi fourths. So as we go around and we do this in 12 total sections here, a 12th of a 2 pi rotation would be a 2 pi 12th, or in other words, a pi 6th rotation. And so again, what you're going to see up here is that we have this is either 0 or 2 pi, however you want to interpret it. Over here we have 180 degrees is the same thing as pi radians. This is our pi halves. And I'm going to go ahead and fill this one down in here. We say this is 3 90-degree rotations, so 3 pi halves rotations. But what you're going to see up here is this. We're going to go by a 1/6 of pi. And you can clearly see that this upper half right here is split into 6 equal pieces, and then the lower half into 6 equal pieces. Each one of these is a 1/6 of a pi rotation. So we have 1 pi 6th. Here we're going to write 2 pi 6th, or that reduces to a 1/3 of a pi rotation. Here we have 3 pi 6th, which is the same thing as this pi halves. So 4 pi 6th, 5 pi 6th, and then 6 pi 6th. And I'm going to ask you to actually go around and fill in 7, 8, 9, 10, 11, and 12 pi 6. But what I want you to see is that some of these, like 5 pi 6 and pi 6, simply don't reduce, but some of these, like 3 pi 6 or pi thirds, or sorry, 2 pi 6, which reduces to pi thirds, or 4 pi 6, which is 2 pi thirds. some of these reduce. And so in terms of common angles, what you're going to see a lot of the time, and I'm going to direct your eyes kind of up to these two circles here, these basically illustrate the degree and radian measurements of angles that we're going to commonly see in trig. And so this first circle you see here, at least angles in standard position, this rotates counterclockwise, and so these are all the positive angles. And over here on the right side, we're going to rotate clockwise, so just these are the negative angles. But what you see are the degree measurements and then their corresponding radian measurements. And so we can certainly, I guess, navigate back and forth between those by converting, but it's good to know these. And so you're going to see these angles that we see here. We see that we have pi 6, which is a 30-degree rotation. Two 30-degree rotations would be a 60. So we got pi 6 and pi 6 is 2 pi 6. But remember, 2 pi 6 was pi thirds. So here's our pi thirds. This is our 3 pi 6, but that's the same thing as pi halves. We have 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6. You know, and it goes on forever and ever. 10 pi 6 and 11 pi 6 and back to 12 pi 6. And then all these between increments, these ones that you see here, these are half 90-degree angles here. And so these are increments of 45s, or what we commonly refer to as pi force increments there. So we're going to see that these angles occur quite a bit of the time here. And so this chart that you see over here on the right is just kind of a nifty way of saying that, you know, we've got a 1/12 of a revolution, eighth, a sixth, a fourth, a third, a half, a 2/3, so on and so forth. But all of these different angles that you see showing up are just these numbers of revolutions. So a 1/12 of a revolution would be a 1/12 of 360, would be a 1/12 of 360 is 30, you know, and that's the same thing as our pi 6 here, which is a 1/12 of 2 pi. So just getting used to pi 6, pi fourths, and pi thirds and pi halves increments. So we're going to list these out here pretty quickly. We're going to say that a pi halves increment is a 90-degree rotation. A pi sixth, which is a sixth of 180, is a 30-degree rotation, while a pi thirds, which is a third of 180, is a 60-degree rotation. And then our last very common one, fairly common one, is a fourth of pi, which is a 45-degree angle here. And so I kind of always remember that a sixth of pi goes with this 30-degree, but a third of pi goes with the 60-degree, and they're kind of backwards like that. So what we're going to do is we're just going to basically, using what we know about these radian measurements, we're going to quickly sketch and label these in standard position. So for this first angle theta here, standard position just means that we're going to leave the positive x-axis. So its initial side would be here at 0 radians, and we're going to rotate, because it's negative, clockwise a fourth of pi. So this, remember that a negative pi half, that's a negative 90 right there. A fourth of pi would be halfway in between 0 and negative 90 here. So we'd say that this right here, we would just say is a negative pi force radian measurement right there, and it terminates in the fourth quadrant. So that is a negative pi force radian sketch. Now looking at 3 pi force, remember that when we sketch these, one really good way to do this is to kind of visualize, at least here at 0 and at pi, how many force this would be, or we could call this or 2 pi. But the way to look at this is we say pi wholes and 2 pi wholes. That would be the same thing as 4 pi fourths and 8 pi force if we kind of look at it this way. And so 3 pi force is like saying, envision this top portion here from 0 to pi being split up into 4 equal sized pieces. We're going to rotate 1 pi fourth, 2 pi fourths, 3 pi fourths. And so our terminal side would be in the second quadrant here. We will label this as 3 45-degree angle rotations there. 3 pi fourths terminate in the second quadrant. So now negative 7 pi fourths. Let's take a look at it. So for this angle up here, beta, negative 7 pi fourths, well, we're starting on the positive x-axis, and we're rotating in a clockwise direction because it's negative. But remembering that 45s are like pi fourths here, we have negative 1 pi fourth, negative 2 pi fourths, negative 3 pi fourths, negative 4 pi fourths, negative 5 pi fourths, negative 6 pi fourths, negative 7 pi fourths. And so we would say that our negative 7 pi fourths here would just be this angle right here. We would label this negative 7 pi fourths. And we can see that this terminates in quadrant 1. And then last but not least here, our 13 pi fourths. This is an interesting one. And in terms of interpreting this in terms of pi fourths, we would say that this is, 0 or 2 pi. This is pi. Let's convert this into fourths. So if we convert these into fourths, we have 4 pi fourths here. Here we have 8 pi fourths. And so what we end up with is a total rotation of 8 pi fourths in a counterclockwise fashion. But we would have to go to 13 pi fourths, which is 5 more pi fourths. We have, 9 pi fourths, 10 pi fourths, 11 pi fourths, 12 pi fourths, 13 pi fourths. So to go at an angle over 360 degrees or over 2 pi would just look like this. We have this little curly Q. We would label this as having 13 45-degree angle rotations or 13 fourth pi rotations. Cheers.